deep in the Allegheny Mountains of West Virginia, in the middle of a rugged 13,000 square mile expanse known as the National Radio Quiet Zone, where the tools of our wireless age, like cell phones and Wi-Fi, are forbidden. A team of astronomers has detected a series of devastating high-energy bursts erupting from an unknown source far off in space.
We've been absolutely confident that these are extragalactic sources.
The signals keep coming.
So we've now detected hundreds of bursts.
And no one has a clear answer why.
What is actually giving rise to these very powerful flashes?
Astronomers are now searching these same skies for clues to help solve a new mystery. The source of a string of unidentified signals they call fast radio bursts. They will do so by scanning the cosmos for radio waves.
A radio telescope is like any other telescope. It collects radiation from the sky.
The enforced silence around the telescope allows it to detect signals that few others can. "45 years into its journey, the Voyager spacecraft has left the solar system. It's more than 11 billion miles from Earth, beyond the reach of our sun. A faint beacon is its only connection to its home planet.
And it's emitting a radio signal which has the equivalent energy of about a 20 or 25 watt light bulb.
Astronomers at the Green Bank Telescope make an attempt to track Voyager down. They find it in a matter of seconds.
But we can pick that signal up with the GBT. It's actually a really bright signal, no problem at all. The signals that we're detecting from fast radio bursts are even weaker than that.
When fast radio bursts erupt, they can unleash as much energy as our sun does in an entire year, in a fraction of a second. But by the time that energy reaches Earth, it's a mere whisper. And while astronomers have now detected dozens of different fast radio bursts, one of them is different from the rest, and they're determined to find out why. They call it FRB 121102. They could now track the location of the signal to the constellation of Auriga.
Once we were able to localize 121102, we realized that this galaxy has never been seen before.
You know, sometimes I try to think about the incredible scale of all the distant objects that we're listening to, and it boggles the mind.
They now knew where FRB 121102 was coming from, but they still didn't know what was generating the signal. But each subsequent flash of energy helped them narrow down their list of suspects. To demonstrate what an encoded message could look and sound like, Andrew Seymour has created one from scratch. Each pixel in this image of the Green Bank Observatory's logo corresponds to a different frequency and time. Think about them like a series of notes on a sheet of music.
Here, instead of having 7 or 12 notes that we may have on other instruments, we have over 1,000 notes being played here.
When all of those notes are played together, we see and hear this. And if we were to broadcast those frequencies into space,
If another civilization was recording with computers the same way we are, they would see this image come across their computer screens.
but when Andrew analyzed the signal from one of FRB 121102's bursts, he discovered something very different.
Magnetars have the strongest magnetic fields in the universe. If you were to take a magnetar and place it at the distance of the moon, which would not be a good idea because it would destroy the Earth, but in the process, it would also erase all of the computer hard drives and credit cards on the Earth because of the strength of the magnetic field.
What a magnetar would do to a human body is even more alarming.
It will actually start to elongate the molecules in your body, and it would rip the water out of your body because those molecules themselves are slightly magnetic. It's not going to end well for you.
When a crack forms on a magnetar's rigid surface, it can set off a starquake, ejecting so much energy that it can be felt billions of light years across the universe. Magnetars are extremely rare on their own, and when scientists observed the radio waves from FRB 121102, they discovered something rarer still.
We saw that they were really twisted up, kind of like a corkscrew. And the degree of twist is higher than in any other source of radio waves that we've ever detected. So we think that this could be a sign that FRB 121102 is itself living somewhere near a black hole.
With radio telescopes like the GBT, astronomers are peering into deep space, tracing a series of cataclysmic events from deep time. A white-hot magnetar nestled in the orbit of a black hole, firing off instantaneous bursts of energy that billions of years later can be observed from Earth. But with every new discovery comes a new set of questions.
Within our own galaxy, we have something that's very similar. So why are these energetic events happening in other galaxies, but yet not our own?
The growing number of signals picked up by the world's radio telescopes are generating an ever-increasing flow of information from across time and space. There is no limit to what they might tell us about our universe, so long as we remain curious and continue to look and listen to the stars.